Today we're going to explore what's called the factor theorem, and we're going to start by looking at a synthetic substitution example. So we're going to evaluate f of -6 for this function using synthetic substitution. So we know that that means that we need to put our -6 in the box. Then I'm going to set up my synthetic division table, right? And our goal with synthetic substitution to evaluate functions, right, is of course to find the remainder number. So our answer is going to be what's over here. So putting in my coefficients, I have 9, 59, 38, and 48, and then we're just going to go through synthetic division. So drop down the 9 and then multiply by the box number. So I'm going to get 9 times -6 is -54. Add down and I'm going to get 5 left over. -6 times 5 is -30. Add down again, we get 8. And then -6 times 8 is -48. And when I add down, I get a remainder of 0. So this tells me that f of -6 is equal to 0. But what does that mean? So, right, that means the x-coordinate is -6 and the y-coordinate is 0. So that means that the point -6, 0 is on the graph. Right, and whenever the y-coordinate is 0, that's a special feature of a polynomial graph, right? That's a special graph characteristic that we have a name for. So I'm gonna actually switch my screen for a second. Right, I actually went ahead and graphed the function. Right, and it's this weird, really tall looking polynomial. I'm gonna adjust my window for my x's. Just to make it a little wider. Right, so if we're looking at it, right, it's like this funky polynomial, right, it goes really high up there, but the point -6, 0 is on the graph, and that's where the x-intercept is. So what this tells us is that -6 is a root of the polynomial, right, root or x-intercept of f of x. Another way that we can say that is, right, I'm going to actually change my handwriting here a little bit, right, x equaling -6 is a root or the x-intercept of the function, and then that means that x plus 6 is a factor of this polynomial f of x. Right, because if we have x equals -6, if we make that equal to 0 by adding 6 to both sides, we get x plus 6 equals 0, so that would have been the factor. And that's essentially what the factor theorem is. So we're going to formally define the factor theorem and go through a couple examples of how we use it. So officially what the factor theorem says is the binomial x minus a number. Most books or something will use a variable there, like x minus a or x minus c or whatever. I'm just going to use x minus a number, is a factor of a polynomial f of x right, and remember what it means to be a factor is that it evenly goes into it, right? So we could use that to help break down something, right? A factor of 6 is 2 and 3, right? It's a factor is something that multiplies by something else to give you back whatever you're looking for. So this binomial x minus a is a factor of a polynomial f of x if the function value at that number is equal to 0. So aka there's no remainder after you divide. Specifically after you divide f of x by x minus a number. So really what this factor theorem allows us to do is to use synthetic division to quickly check if something is a factor. And if it is a factor, it allows us to break down polynomials into smaller pieces, which are oftentimes more easy to work with and allow us to solve for the other x-intercepts. So we're going to do 2 examples for this. So we're going to determine if the given binomial is a factor of the polynomial, and if it is a factor, we're going to break down the polynomial to find the other factors. So we're going to look at the one on the left first. I'm going to divide my two problems out here so it's easy to separate them. Right, so we want to know if x minus 4 is a factor of f of x equaling 2x cubed minus 5x squared minus 17x plus 13. So what we're going to do is we're just going to divide. Right, so we're going to set up our synthetic division. I need a column for x cubed, x squared, x in my constants. And then I'm going to put positive 4 inside of my dividend box, my divisor box, I should say. Right, so drop the 2, multiply by 4, add down, multiply by 4, add down, multiply by 4, add down, so I get negative 7. So we're going to say because of this number here, right, since we have a remainder of negative 7, right, what we can say is x minus 4 is not a factor of this polynomial f of x, right? Since there is a remainder of negative 7, or another way to say that is since the function evaluated at 4 equals negative 7 and not 0. Okay, so let's look at number 2. So in number 2, we're going to say, okay, we want to know if x plus 3 is a factor of that polynomial, x to the 4th plus 8x cubed plus 22x squared plus 56x plus 105, right? It's a really big polynomial, right? Bigger than the other one. So again, we're going to set up our division. I'm going to put negative 3 in my divisor box this time since I have x plus 3. Set up my columns. All right, if you want to try this one by yourself, feel free to pause the video, figure out the answer, and then unpause the video and check yourself. Right, so I have 1x4, 8x cubed, 22x squared, 56 x's, and 105 constants. I'm a little squished over there, so let's move this over. Okay, drop the 1, multiply by negative 3, add down, multiply by negative 3, add down. All right, and then multiply by negative 3, and I get negative 105. So when I divide, I do in fact get that x plus 3 is a factor since it's equal to 0. So we can say, right, x plus 3 is a factor. So that was the first part of what the question asks us to do, is we determined if it was a factor, it is, and then the second part says, if it is a factor, find the other factors. So we're going to keep breaking it down. So if we look at what's left over, our leftover function is 1x cubed plus 5x squared plus 7x plus 35, right? And all I'm doing, right, is I'm taking our quotient from our synthetic division and putting the variables back in, right? Just like a normal synthetic division problem. So if I want to find the other factors, that means I need to factor this equation. Okay, so I have 4 terms, so that clues me in that I probably want to try factoring by grouping, right? Because there's no other real way to factor a 4-term polynomial. So I'm going to split my equation in half, right? I can divide both of these things on my left group by x squared, take out a GCF of x squared. And I'm going to be left with x plus 5. And then my GCF for my right group is positive 7. And when I take that out, I'm left with x plus 5 over here. So then if I rearrange my factors, right, factor out the common group of x plus 5, and put my leftover terms, my 2 GCFs, in my second group, right? Those are the other 2 factors, right? So if we look back at our original polynomial, we can say the original polynomial f of x equals x plus 3, since that was a factor, times, right, the x plus 5 factor that we just found, times the x squared plus 7. So our total answer is that these are the 3 factors of our equation.